And here is the assignment. I said we have Taye, Kehinde, Idowu, Alaba, James. Yeah. So I want us to say something like, my name is Taye, my name is Kehinde, my name is Idowu, my name is Alaba, my name is James. And what you can do is this. You can use a loop like this for name in names. Name represents each item in names. Now, please note where this indentation is, this cursor is. If I say print name, that's going to print Taye, then it will print Kehinde, it will print Idowu, it will print Alaba, it will print James. But instead of saying that, I can now say print. Remember in the last class we looked at concatenation. So we can say my name is name. So this is going to print my name is Taye. Then it's going to print my name is Kehinde. Then it's going to print my name is Idowu. Then it's going to print my name is Alaba. Then it's going to print my name is James. Please, do you have any question on that part? Please, can you hear me? Hello, Mans. Please, can you hear me?
Yes, you can hear you, sir.
Yes.
Okay. Do you have any question on
I
this?
think there's a mistake.
Okay, ma. What's the mistake?
Hey, sorry. I don't know.
Okay.
What you thought is for names in anything, print anything.
I said this
So
can
for name in names.
this can be anything, right? Anything represents each of the values there. So I can say my name is anything. Do you get it, man? This anything represents each of the values here. Anything will first be Taye, it will print my name is Taye. Then anything represents Kehinde, then it's going to print my name is Kehinde. Then anything represents Idowu, it's going to print my name is Idowu. Then anything represents Alaba, it's going to print my name is Alaba. Then anything represents James, then it's going to print my name is James. Do you get it, man?
Can we say for value in names, print
Exactly. Yes.
and it still goes.
It will still work. This can be, that's why I use the word anything, that so that we can know that it can be anything, like anything can be anything. But oftentimes we use the singular form of this. That is, since this is names, this we usually call it name because it stands for each of the value inside these names. So that's why we use something like for name in names. But it's not a must to call it name. You can call it anything. That is, if this is students, this will be for students in students. But it is not because it is the singular form that makes it work. It is because it can be anything and it will still work. Do we get it? Hello, Mas.
Yes.
Okay, ma.
Yes.
Okay, ma. So, if you want to add new values into this place, into this list, we use append. Append. So, let's go to a new tab, add a new cell to it. We can say names. Let me make it bigger. Dots. Append. You can append Tolu to it. So it will add Tolu into this list. And when you say print names, we'll see Tolu inside of it. You see Tolu inside of it. Now, but what if we want to get this input from users? We want users to enter it. How do we do that? Now this Tolu is static. That is, we are not getting it from users. But what if you want to get it from users? So we use something called inputs. When you run input like this, users can type input here. And whatever the user enter, if the user enter John, then it will take it as the input, right? So this word input, it instructs the code that, see, this person wants to take an input. You say fail. Am I still connected? Okay, yeah. So this input is used to take inputs from users. Now, if I run this code, and you can see, let's run it again. You see, it displayed an input. Right. But then the user does not know what he or she is to type inside the input. There's an input, but I don't know what I'm to input there. So instead of, you can put some text here to make the user know what he or she is to type. You can say enter your name. Enter your name. So whatever text you put inside this code will be displayed to the users. Now if I run this code again now, it's going to display this enter your name. Let's stop this and run this cell. I'm coming. I want to do this faster. Now let's run this cell. Now we have enter your name. So now the user now know that, oh, I'm to enter my name inside this input. Initially, it just displayed an input, but the user did not know what to do with this input. But now, the user knows what to do with the input now, because the user knows that, oh, I'm to enter my name. So let's assume I entered Esther inside the input. So the user has entered Esther. Do we get it?
Yeah.
So next is, whatever name the user enters here, I want to add it as part of these lists. I want to find a way to push it inside these names. So remember, to add a value to a list, you use append. So we can come here and create a variable called new name. New name. Variable, remember, variables are boxes. They are containers where you store values. And one uses of variable is that it allows us to use a value sometime in the future. That is, you can keep it in a box so as to make use of it later in the future. So what you are doing is that whatever input the user enters here becomes the value of this new name. That is, if the user entered Ajayi here, new name becomes Ajayi. If the user entered Ojo here, new name becomes Ojo. If the user entered Tolu here, new names become Tolu. If the user entered Bibitaya here, new names becomes Bibitaya. Do you get it?
Yes.
Alright. So we can now say names dot append. Instead of saying append Tolu or append this, we can now say append new name. Since we know that new name stands for whatever the user entered here, so it's going to push it as part of the list. Now if you now print out names, remember, instead of saying print, you can just say names, right? As long as it's the last thing there on that line, is to print it out. So when you print names now, you will see the new name that was entered here inside the names. So let's run this part again. Now enter new name, let's say BB. So now we have BB as part of the names. Questions. Okay, let's proceed. But the thing is, okay, let's go to the next cell. So let's go to the next cell. Now the thing is this. Let's assume I have a list of numbers. Let's say vars. Right. And it looks like this: 4, 7, 10, 20. So here is a list of numbers. I want to multiply each value inside this list by 2. Now see what is happening. Vars times 2 is not giving us what we want. Right? What I want to do is I want to multiply 4 by 2, 7 by 2, 10 by 2, 20 by 2. You know, one thing we can do is that you say for maybe var, let's call up for var in vars, I can now say print var times 2. Right. You know, var represents each of the values there. Var will first be 4. 4 times 2, that's 8. Then var becomes 7. 7 times 2, that's 14. Then var becomes 10. 10 times 2, that's 20. Then var becomes 20. 20 times 2, that's 40. Do we get that part?
Yes.
Okay. But I'm not just interested in multiplying it by 2. I want to save these results inside another list. I come again. We are not just interested in multiplying it by 2, but we want to save the results inside another list. That means we want to have a new list. That new list will now have 8, 14, 20, and 40 inside of it. So one thing we can do is that we can say new vars, we can call it any name. I just like to call it new vars, equals to an empty list. That is, there's nothing inside this list initially. So we can now say new vars dot append var times 2. That is, multiply var by 2 and append it inside new vars. So inside new vars now, if you print new vars at the end of everything, if you print, you will see a new list that contains 8, 14, 20, and 40. So we have a new list that contains 8, 14, 20, and 40. Now when you are working, we are going to be doing something like this a lot of times. That is, you have a list, oftentimes a list of numbers like this. And maybe you want to multiply each number inside this list by 10. Or you want to subtract a particular value from each of the number inside the list. Or you want to square each of the numbers in this list. Right? So that when you square it, you want to create a new list and save them inside of that. Do we get it? I come again. We have a list. We want to take each value inside this list and multiply it by 2. And that's what we are doing here, var times 2. But we are not just multiplying it by 2. We want to save the result inside a new list, so that we don't tamper with the first list. Now, we have vars, which is this list. And we now have new vars, which is this one. That is, times 2 of each value in vars. That is the new vars. Do you understand this? Please, do we get it, Mas? Are we following? Okay. Oh, network. Please, can you hear me?
Lost.
Oh, sorry.
We lost you for a few seconds.
Okay, I think it's back now. Okay. So, what I was trying to explain is that a lot of times you have a list of numbers like this. And in that list of numbers, we want to multiply each value in that list by 2. In our own task, in the task we want to do, you just may not be multiplying by 2. You just may be, that is, multiply each number by 10. You just maybe subtract 20 from each number inside that list. As a data scientist, we are going to be dealing with numbers a lot. So just maybe that, okay, have a list and maybe square each value inside this list. So when you square it, you want to save the result inside a new list. And this is one thing, this is the approach we can make use of. Do we get it?
Yeah.
Right. But because we're going to be doing this a lot, right, and we're going to be doing a lot of other numerical operations a lot. Now, there is a tool for us. That is, you don't need to write all of this. There is a way you can simplify this. And that's why data science is easier now. Instead of doing all of these things yourself, doing these things manually, we now have different libraries that do these things for us. One of them is called numpy. NumPy allows us to do a lot of numerical operations like something like numerical Python, right? NumPy. So let's see how we can make use of NumPy to do these things for us, so that we will not be using raw Python like this. We're not going to be using the raw programming language, but instead we make use of a tool that will simplify our work. So let's do that together. Please, any question before we move on?
No, I have a question because I know this is a language that we need to read. That we like it. You will learn it.
Okay. Now, normally we ought to first sit down with Python and learn it from scratch, right? But what I'm trying to do is that, like I said, I'm trying to shunt it. Like, instead of spending time to learn Python alone, we are learning it with the tools. As we learn Python, we are learning the tools alongside it. So now we are learning NumPy. To use a tool, you come here and say import NumPy. NumPy like this. So it will import NumPy, right? But you can give it an alias. Oftentimes we call it NP. That instead of typing NumPy in full, you can always call on NP. Do you get it? This is an alias. You can call it Taye. That instead of typing NumPy now, all I need to do is to call on Taye. So, but the common thing is to call it NP. Import NumPy as NP. That is, anytime I call on NP now, I'm calling on NumPy. Do you understand it?
Yeah.
Okay. Madam Esther, how are you there, man?
Yes, sir. Yes, sir.
Okay, man. Now, this NumPy, you can use it to create a list also. Remember, in our last class, we said, if you want to generate, if I say range 10, please, what will this give us? In Python now. Okay, this is it. So if you say range, you can say range 2 to 10. That is, starts from 2 and end at 10. But it's not going to include 10 itself. It will not include 10 itself. So range 2, 10 is like saying 2, 3, 4, 5, 6, 7, 8, 9. Do we get it?
Okay.
Range 2, 10, that is start at 2, end at 10. But it's not going to include 10. If I say range, let's say 12, 18, 18, that's like saying 12, 13, 14, 15, 16, 17. It won't include 18 itself. Start at 12, end at 18, but don't include 18. Now, if I say range 0, 5, that is start at 0 and end at 5. 0, 1, 2, 3, 4. It's not going to include 5 itself. Now, range of, we are also allowed to just use range 5. Range 5 is the same as saying 0, 5. That is 0, 1, 2, 3, 4. If I say range 10, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Do you get it? Do we understand this?
Yes.
Okay. So range 10, range 5, range. We use range a lot. If you just want to generate if I want to generate 1 to 1000, I will just say range 1, 1001. So it's going to generate a number from 1 and end at 1000. Let's print this. Let's remove this part now. Let's print this out. So, say for var in range. This you can say print var. So you can see when you scroll down. So 1000, right? If you scroll up here, okay, it's only displaying the last set of values, but this starts from 0, 1 to So this is so good. You don't need to start typing 1, 2, 3, 4, 5. So you can just easily make yourself range to do that. If I want to display just the odd numbers alone, I can put comma 2 here. I will explain this here, this skip. As you can see, this will only display the odd numbers for us. Oops. 1, 3, 5, 7, 9. Because the way range works is that when you say range, let's say 10, 20, and you put a third value. I come again. When you put a third value, let's say 4. You know, normally range 10, 20 should look like this: 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Normally, this is how it should look like. But once you add a new value, making it 3 now, what it's going to look like will be this: 10, it will add 4 to it, 11, 12, 13, 14, it will remove all of this and jump to the next 4, like it will add 4 to it. Then add 4 again to this one, it will remove all of this and jump to 18. And jump to 18. Then because the last value here is 20, so you won't see this 19. So the result of 10, 24 will be 10, 14, and 18. Do you understand this?
Yes.
Okay. So that is the way it works. Now, but instead of doing this, we also have that in numpy. Numpy allows us to easily manipulate arithmetic operations, arithmetic values like this. So let's bring in our numpy. Please, do we know the meaning of this hash at the beginning?
No.
Okay, this hash there means comment. That is, I'm telling Python to ignore this, everything here. Once you put hash at the beginning of a line or at the beginning of a text, you are saying that ignore this. That is, if I run this now, I'm not going to see anything because there is nothing here. I'm telling Python to ignore these 3 lines. So this is commenting. That is, you're adding some text that you want Python to ignore. It's just like, the reason we call it comments is because if both of us are working together and I don't want Python to reach that part, but I want to drop some text for you to see. Maybe I want you to understand the reason I did it like that. I will just add some comments. Because those comments, for instance, I want to say that, oh, I'm making in Python to make my work easier. I'm making in numpy to make my work easier. You know, if I type, I am bringing in numpy to make the work easier. If you run this will throw an error because Python does not understand all of this. So I can comment it, just put hash at the beginning. The shortcut is console/. So when you execute this cell now, Python will ignore this line. So it's mainly for your fellow developers to know some things. It's just like you're adding some text, some comments to something, but you don't want to execute them. So Python will ignore that part. Do we get it?
Yes.
Okay. So these are some comments. So let's bring in our numpy now. If we need to bring it in, so we need to remove the hash at the beginning so that Python can now see it. So instead of using range now, numpy has something called a range. A range. So you say np dot a range. It's like this. A range. It works like the range that we have here. So if I want to generate a range of numbers, let's say from 10 to 20, that will be 10, 21. So this will generate like some numbers from 10 to 20. It will stop at 20. Remember, this is not inclusive, non-inclusive. It's not going to include this 21. And that's why we have this here. You can save it in a value. You can call it vars equals to this. So let's print vars. So we have this. Now, the good thing about this numpy array is this. it is easier to manipulate. Remember when we did vars times 2 here the other time, it did not work, right? But if I come here and I say vars times 2, what you should do is that you should pick each value here and multiply by 2. That is, you're going to see 20, 22, 24, 26, and the likes. So it has multiplied all of them by 2, each value inside it. So it is easier to manipulate. You can save it inside a new vars. So now print out new vars. Again, the essence of bringing this numpy is to make our work easier. So this, but instead of going to this long approach, this is better or faster. Any questions so far?
No.
So let's create a list of, let's say, values, maybe from 30 to 40, and we want to square each value inside it. So let's go to the next cell. We can say nums equals to mp dot arange 30 to 40, then square it. We can say nums dot nums to square here. What you get today is that you say you use double star, that is multiplied by itself. If I put 3 here, you are, what do we call it, opposite of cube root. That is, you are multiplying by itself 3 times. Do we get it?
Yes, sir.
Cube, you are cubing it, something like that. So it's going to multiply each value there. Thank you, ma. It's going to multiply each value there by itself 3 times. Thank you, ma. So we can save it in a new nums. Let's call it nums cube, since that's what it's doing. Nums cube equals to the then print it out. Let's print out nums cube. You can see what happened is that I picked this value, multiplying it by itself 3 times, and we have this results. Yeah. Any question? Any question? That is 30 multiplied by itself 3 times. We have this. 31 multiplied by itself 3 times. 32 multiplied by itself 3 times by 3. Now, class work. Our class work will be more like continuation of this. But what I want you to do for me is that I want you to pick all the even numbers between 30 and 40. Then you square them. Do we understand it? Pick all the even numbers between 30 and 40. Then you square them. Do we understand? Just can you tell me what to do? Okay. Just can you tell me what to do? I want us to pick all the even numbers between 30 and 40. Then
We should do it now.
You can do it now, or you can tell me what to type.
Okay. Give me 1 second.
Okay.
Phone, come on with me. Even numbers. As you are doing it, I was doing screenshots. So.
Okay.
Okay. So, okay, between what, 30 and 40?
Yes, ma'am.
So we put 30, 40, then we put 2.
Okay.
I don't know.
Exactly. Yes, ma'am. 30, 40, 2. Okay, what next am I to type?
Hello, sir.
Yes, ma'am. I'm with you, ma'am.
Okay, you said we should print even number between this and this and multiply by what?
And like square it, each of the even numbers.
So we should square. Okay, if we are to square each of the even, come here. So if we are to square each of that even number, okay, so it's going to be to square. Okay, it's going to be. Okay, we cannot say nums square is equal to
Okay.
nums star star.
Like this? Nums square. Like this, man. Is it like this?
Like nums underscore square
Okay, man.
is equals to
Okay, man.
nums
Okay, man.
star star.
Okay, man.
I'm coming. Let me look at what you've done. Okay, but we need to name our nums.
Okay, man.
We need to name our nums to be that it's equal to numpy dot arrange. Then we have bracket
Good. Nums equals to this, correct? Okay.
I think we should get it.
Okay, we should stop.
Two.
Okay, good. Good. Well done, man. So we can now display the results. Well done, man. Senior developer.
I mean that I'm the screenshotting, but I'm trying.
Well done, man. So we have this, right? We have this. So we have all the even numbers between 30 and 40. But if you look at the results, 40 square is not inside this place, but I want you to include 40 square also. How do I go about it? You know, 30 square is this, 31 square is this.
You put it to 41 now.
Good, thank you, man. 41, good. Nice one. Senior devs. Okay, now, so this
you know,
is...
if I say I'm serious.
Okay. So this is how we can use arange, numpy.arange to make our work much easier. So assignments. We meet again tomorrow. The assignment will just be a small assignment. Now display, pick all the multiples of 5. All the multiples of 5. Right. That are between, let me type it out. Pick all the multiples of 5 that are between 5 and 200, then multiply them by 10. Display the results.
Very simple.
Pick out the multiples of 5 that are between 5 and 200, then display.
This is going to be multiplied by 10. So it's going to be just one star. It's not going to be star 2.
Good. Thank you, man. So pick out the multiples of 5. Then of course, let the 200 be inclusive. That is, this 200 should be part of the result of 30. You know, I want to say 200 times 10. Do you get it? 200 itself should also be part of it. That is, between 5 and 200, not the multiples of 5. Include 5, include 200 as part of it, then multiply it by 10, each of the values inside that list, multiply by 10, then display the results.
I did not trust you. This one I did not talk with what I just said.
It's simple. Yeah, you got it right. You got it right, ma. You got it right. Like, you got it right very well. This our next class is tomorrow. It's good to just do something that will make us practice a bit without tasking us too much also. So next class we are going to look at slicing. How to slice a list using numpy. So I hope we are enjoying.
I know you like students like me, right?
Yes, ma. I really love students like you. Yes, ma.
It's because I know you. I can catch you. That's why. You are wasting my time.
No, ma. No, ma.
Okay, now thank you so much. I really appreciate this. I'm not taking this for granted.
You're
Thank you so
welcome,
much
ma.
for your time,
You're
for
welcome,
your
ma.
knowledge. Thank you so much.
You're welcome, ma.
Thank
Thank
you.
you. Yes, ma. You're welcome, ma. Yes, ma. Agua very, ma.